Hello everyone. In the present lecture, we are going to see the interference pattern by Lloyd mirror. Lloyd mirror is a plane mirror. This plane mirror is thick. Its length is up to 30 centimeter and its breadth can be 6 to 8 centimeter. Thick mirror. So virtual sources are here obtained. These coherent sources are obtained by using a plane mirror. Let us see here in the diagram. Let a Lloyd mirror is here. Thick mirror Lloyd is here. In this case. Now see carefully here in this diagram. Take a dotted line here and treat this vertical line as a screen where interference fringes will be formed. Let here is a source S. Source S is source of monochromatic light is here, and by this source let us see the ray of light falling over Lloyd's mirror. From the upper surface of this Lloyd's mirror, this ray of light reflected in this direction. This ray of light is also some ray of light reflected and some transmitted. Partial reflection, partial transmission from the upper surface, some transmitted, and from internal of this again reflected back. Suppose here reflected and then again transmitted, right? So when is one viewed through the combined surface of this and this reflected ray of light moves back, it seems to come from here a common point S dash. So here S and S dash behaves as coherent sources. We know that this coherent source which fulfill the condition of interference, that is produce light of same frequency and constant phase difference, which is a compulsory condition of it. So this here in this two sources S and S dash, S is the real source and S dash is virtual source. See very carefully. in Young double slit experiment and Fresnel biprism experiment. In both experiments, coherent sources which is framed both are virtual. But here one real, another virtual. The experiment, two virtual sources are obtained, and when we see this is here one ray of light we may take like this also. Here in it, the interference pattern obtained here in this region. So telescope is here used to see and record the position of fringes here in it. Since this fringe pattern, that is interference patterns formed here due to the superposition of two reflected rays, one which is reflected from upper surface of the Lloyd mirror and second from the inner surface of that. So in that condition, the center fringe is dark, appears dark in place of bright. In Young double slit experiment and Fresnel biprism experiment, the center fringe is obtained bright, but here it's appear dark. Why it's appear dark? For that we have to see famous Stokes theorem. According to this Stokes theorem, light suffers a phase change of pi degree. See this statement. The light suffers if a phase change of pi 180 degree or pi when reflected from a thick mirror from lower and upper surface. So from it reflected in the rare medium and it reflected in the denser medium. So between two rays there is a, at the center it suffer a phase change. Change of pi. So in place of being get center fringe as a bright, dark fringes are obtained, and this is due to only the Stokes theorem, and rest of the thing is same. Fringe width beta can be obtained by same formula, lambda capital D by 2 in this case. The everything is the same, but the difference is only center fringe is a dark in place of bright. This is for the topic, students, to show the phenomena of interference pattern due to thick Lloyd mirror. So this is for the topic. Thank you and have a nice day.